Hi, this is Mr. Barron. I'm going to be showing you how to do colorimetry. Colorimetry is a process of using light to measure the concentration of a solution. Concentration, of course, is how much of a solute is dissolved in it, and in this case, I have a bunch of copper dissolved in here. What I did is I took a penny, and it was either before 1982 or after 1982, somewhere around that date. I don't know exactly where the cutoff is, but certainly a penny from the 70s, or I chose a penny from today. The difference between those pennies is that the ones made before around 1982 are made with 98% copper. Those after 1982 are made with only about 2% copper. So obviously, you're getting shortchanged when it comes to the amount of copper in your modern pennies. So what we're going to do is figure out the age of the penny, or at least relative age of the penny, based on how much copper is in this solution, because I dissolved the penny with acid. And the reason it's blue is because of copper 2+ ions. So again, the question of the lab is, what's the concentration of copper ions in your unknown solution? And your unknown solution is this guy right here. I want to know how much copper is in here. So the way we figure it out is with a colorimeter. Colorimetry works by shining light through a sample, through these little plastic things, which are called a cuvette. What it does is you put your unknown sample in it, and a little LED shines light through it, and then you have a detector. And the more light that makes it through, the less blue your solution is, in a sense. And in fact, the less concentrated your solution is. So you can use a reading of how much light actually makes it through your sample to figure out the concentration. So the higher the transmittance, the lower the concentration. It's inversely proportional. But in this lab, our colorimeters will actually be giving us absorbance readings, which is the opposite of transmittance, meaning the less light that makes it through, the higher the concentration of your solution. Because we can see from the blue, the more blue this is, the more copper ions in the solution. Therefore, we can use the amount of light passing through it as a measure of how much it is in it. So back to the PowerPoint. This brings us to Beer's law. Beer's law is a relationship between absorbance and concentration. There is this one little factor here, constant, which we'll talk about in a second. So Beer's law, let's talk about it more specifically. What exactly is this device doing? So what it does is it emits light using a certain current, particular amps, and then it measures how much current is produced by a detector. The ratio between those two is your transmittance. There's the relationship between absorbance and transmittance. And then this right here, the epsilon and the B, that's your K. B is the path length. The more solution the light has to travel through, the more it's going to seem like more light's being absorbed. So this is something very important that's going to be kept constant because you're using a cuvette, is that the light is always going to be passing through the same amount of solution in terms of the distance it has to travel from here to here. And that's a factor that affects it, but we're not really going to see that in this lab because we're using cuvettes. All right, now this is the equation. These are the two equations that you definitely do need to write down because our devices also deal with percent transmittance. This is absolute transmittance. This is more of our percentage number. All right, moving on. So this is an example experiment to help you understand how you are going to figure out how much copper is in your solution. Say I want to know how much red dye is in Gatorade. So here's red 40. Red 40 is a molecule that looks like this. And say this is about pure red 40. And I want to know how much of this pure red 40 is in the Gatorade. Well, I look, obviously it's a darker color because it's a higher concentration than the unknown. What's important is that the Gatorade, which has red 40 in it to make it red, has an unknown concentration. This is our known. It's by doing a comparison between the known and the unknown that tells us what the concentration of red dye is in our Gatorade. So what we do is we take our known and then we dilute it down. We dilute it down, and this is called a bunch of serial dilutions. And we look and we're like, hey, you know what? This color kind of looks like 80. Maybe it is 80. Well, that's a qualitative observation. We want to use these samples to quantitatively analyze for concentration. That's where we use a colorimeter. So one of the things that we need to know about a colorimeter is that, and I'm going to jump out to show my blue over here, is that the reason this looks blue is because blue light's being reflected and it's coming out through your screen, and that's what you see. It turns out that all the other wavelengths of white light that are in white light are being absorbed. So whatever color we see is what's being reflected. Remember, in this lab, a colorimeter is not measuring stuff being reflected. It's measuring stuff going through the sample. And right here, blue's not going through. So what's going through? So we go back here. Turns out, if you want to measure blue dye, you have to use red wavelengths of light. If you want to measure red dye, you have to use blue wavelengths. That's because if you look here at the spectra, red 40 absorbs light mostly at around this wavelength. And that's a short wavelength. That's blue light. And blue absorbs wavelengths of light that are very large, which is like red light. So you use red light in your colorimeter to measure anything that's blue, and you use blue light to measure anything that's red. Now, we do the measurements, and we see that the transmittance and absorbance for each of these known values are the following. Didn't measure the absorbance for these because I was pretty certain that these did not match this. So I measured the absorbance and transmittance for the Gatorade, and I see something. See the absorbance? It's 0.24. That's unfortunately between these two values. So I know it's somewhere between a concentration between 80% and 90%. So how do I figure that out? Create this thing called a calibration curve. I plot all of the concentration on the x-axis, then I plot all of the absorbance on the y-axis. When I do that, I get this thing called a calibration curve. Hit pause, write down the word calibration curve, and you want to draw this out. So you want to make sure that you have absorbance on the y-axis and concentration on the x-axis. And in our lab, we're not going to be using percentage, we're going to be using molarity. So what you do is you know the absorbance of the Gatorade falls in between these two values, and we're going to do something called interpolation. We're going to look between these data points. See, we've drawn a line. We see it's a linear relationship between the two. Because of that, we can say, well, there are data points in between these 2 points which we measured, so we can interpolate and say, well, our unknown had an absorbance here, therefore if I go across and then I go down, it has a concentration here. We need to be more precise than that, so we're actually going to develop an equation for our calibration curve and plug in our y value, which is absorbance, for our unknown to figure out the x value, which is our concentration for our unknown. So the next podcast will be on how to make dilutions and how to do this. Please watch it, and if you have questions, please let me know.